tutorial will show you how to use the quadratic formula to solve a quadratic equation, as well as to determine the discriminant value in order to understand if the quadratic equation has 1, 2, or no solutions. Let's get started. So the target for this video is that you can find the solutions of a quadratic equation using the quadratic formula. And this particular tutorial will teach you both rounding your answer if you get an irrational number, as well as writing it in simplest radical form. So in order to be successful, you need to be able to write equations in standard form. You need to be able to identify what the a, b, and c values are, and you need to substitute those values correctly into the quadratic formula, which will be provided to you. So this is the quadratic formula. I know it looks pretty complicated, but it really is just a small puzzle where you put the numbers in the right places and you will be able to determine the answer. So this is an equation in standard form, where the ax squared, the bx, and the c are all on one side of the equation, and a 0 is on the other side of the equation. If you do not have a 0 over here, you need to use an inverse operation to move that term to the left-hand side so that you have a 0 value. So when you're looking at a quadratic graph, it's very easy to tell if it crosses the x-axis 2 times, 1 time, or not at all. And when you can see that on a graph, these are called the solutions. Right? So the solution to a quadratic equation is its x-intercept value. Sometimes it touches at exactly 1 location, sometimes it touches at 2 locations, and sometimes it doesn't touch at all. So when you have a graph, it's very easy to tell, but when all you're given is a standard form equation and you don't have a picture, it's harder to tell. So when all you have is an equation, we use something called the discriminant. And the discriminant is this value right here that is under the radical sign in the quadratic formula. So this particular expression, when you plug in or substitute the correct values into b, a, and c, this particular value here can help you to determine whether there are 2 x-intercepts, 1 x-intercept, or no x-intercepts. And this is what you do. You determine your a, b, and c values. You substitute them into this expression, and that will determine the number of real solutions that you have. So let's take a look at 3 examples. So 3 things can happen when you substitute numbers into this expression. The number can evaluate out to be a negative number, right? So any negative number. It could come out to be a positive number, or it could come out to be exactly 0. So those are your 3 possible outcomes: a negative number, a positive number, or exactly 0. And when you have a negative value, so let's say you have this equation, and let's say that you identify your a value as 1, your b value is 2, and your c value is 5. And when you substitute them into this discriminant expression, right, by plugging them into the right values, or the right variables, if you get an answer that is negative, that means that there are no solutions, that it's not even possible to get an answer. So if you put this quadratic formula, once we start, put this quadratic formula into your calculator, you're going to get an error message. And that's because the graph never crosses the x-axis. If you put all of your values in to the discriminant formula here, and you get out a 0, if you get out a perfect number 0, that means that you have 1 solution, or you have repeat factors, right? If you're solving by factoring and the factors were the same, that would be 1 solution. If you plug all of your values into the discriminant and your answer is some random positive number, right? It can be any number, it just has to be positive. Then that means there are actually 2 real solutions. There are actually 2 real solutions to this. So if I were to take away the math, if I were to take away all this math, right, it would match with our graphs. So if you have no intercepts, then you have no real solutions. If you have one x-intercept, you have one real solution. And if you have two x-intercepts, then you have two real solutions. So let's take a look here. If I gave you this equation, then in order for you to determine if it has any solutions at all, right, you put it in standard form first. So I take that minus 3 and I move it to the left-hand side. I identify the a, b, and c values, and then I substitute them into my discriminant expression. So in our equation, a is 4, b is 5, and c is 3. So if I fill in this equation with parentheses instead of values, b is 5, a is 4, and c is 3. And then I would pick up my calculator here if I didn't feel like computing all that math on my own, and I would do 5 squared minus 4 parentheses 4 parentheses 3. And I get a negative 23 value. So remember what the rule is. If you have a negative value, then you have no real solutions. So this has no solutions. You still have a parabola, right? It just doesn't intersect the x-axis. That's what that means. It has no roots, it has no zeros, it has no x-intercepts, it has no solutions. So let's try a couple more. First thing is check to see if it's in standard form. Second is identify your a, b, and c values. A is 1, b is negative 8, c is negative 20. Then substitute them into your discriminant expression. So b is negative 8, a is 1, c is negative 20. So I'm going to get 64 minus 80, or plus 80 actually. Negative 4 times negative 20 is plus 80. And that's going to be a positive answer. Even if I didn't add it up, I already know it's going to be a positive answer. When I add this together, I get 144. And so that means I have two real solutions. So I don't know what they are yet, but there are two of them. Let's take a look at this one. Get it into standard form. Identify a, b, and c. Then substitute it into your discriminant formula. So b is 20 squared minus 4 times a times c. Get my calculator out. So I get 20 squared minus 4 times 4 times 25. And I get 0, right? When you get a perfect 0, that means there is one real solution. All right, so that is how you can determine the discriminant value and know that if you're going to have an answer even before you plug it into that fancy quadratic formula. So why don't you try these three on your own, pause the video, and then you can check your answers. Good luck. Okay, let's see how you did. So no solution, two solutions, and one solution were our answers. All right, let's get working on this calculator and using the quadratic formula. So the steps are, first, make sure your equation's in standard form and equal to 0. Step 2, identify a, b, and c, and plug them into the entire formula this time, not just the discriminant. And then we're going to learn two ways. Simplify twice, because there is a plus and a minus sign in this formula, and you can't do them both at the same time. So you're going to write the formula one time with a plus sign, and then you're going to write the formula a second time with a minus sign, and determine your solutions. So let's get started with one that is a rounding question. First, check to make sure it's in standard form. Yes. Second, identify your a, b, and c values. Third, substitute them into that fancy formula. See how I removed all the variables and replaced them with parentheses. Now all I have to do is place those a, b, and c values into the correct place. Then I pick up my fancy calculator right? I clear it out. I type the fraction button here, alpha y equals, and then I type minus, exactly what I see, minus parentheses 4, right? Let me show you there, minus parentheses 4. Then I'm going to choose a plus sign. Then I choose the square root, second x squared, parentheses 4 parentheses squared. I know it feels ridiculous to type all these parentheses, but when there's lots of negatives in here, it can get pretty tricky, as well as obviously timesing by 1 doesn't need to be typed, but I just want to show you exactly how you enter it into your calculator. Okay. So once I press enter, I'm going to get a really long number because my answer is irrational. So I'm going to round that to whatever the question states, and mine says to round to nearest 10. So I'm going to write here negative 0.2, nope, negative 0.3. Okay. Now, I have to do this whole equation again, but I don't feel like typing the whole thing, so I'm just going to copy and paste it, and here I go. I just arrow up on my calculator 2 times until what I want to copy is highlighted. Once I press enter, it will paste it in the editing area. Now all I have to do is back my arrow up all the way to that plus sign. There I go. Now right there where my cursor is flashing, I'm going to change that to a subtraction sign. Press enter, and now I can round my second answer to the nearest 10, negative 3.7. And those are the 2 solutions. So that is how you calculate using the quadratic formula and using your graphing calculator. So you may need to rewind the video, watch the steps again. How do you get the fraction? How do you get the square root sign? How do you copy and paste? But that's pretty it. That's the basic formula. So let's get you started on trying some on your own. All right, pause the video and give these a try. Round to the nearest 10th if necessary. All right, did you pause the video? Hopefully you did. Here are the solutions. Great job. All right, now for the final part of this lesson. What if the directions ask you to solve the equation for all real solutions in simplest form or simplest radical form? All right, this is where it gets a little bit trickier. First, you always follow the same steps. Get this over here on the left-hand side so it is written in standard form. And you still have to identify A, B, and C. And you still have to substitute those values into the quadratic formula. But this time, I'm not going to pick up my calculator just yet. So I'm going to substitute these numbers in. B is 11 plus or minus 11 squared minus 4AC, and then 2A. Okay. So what I'm going to do this time is I'm actually going to calculate this discriminant. Just like I did earlier in the video, I'm going to calculate this discriminant. So I am going to use my calculator, but I'm not going to enter the whole formula. All I'm going to do is enter what's under the radical sign. So let me show you here. I'm going to clear this calculator, and I'm going to enter parentheses 11 squared minus 4 parentheses 1 parentheses 13. So this is my discriminant value. Now it's positive, which is a good sign because that means I know that I have 2 solutions. So what I'm going to do is I'm going to type this. Is that what that said? 69? I'm pretty sure. Yeah, okay. And I'm going to simplify the denominator here, okay? And I'm actually going to even simplify this one up here because negative parentheses 11 is the same as negative 11. And I am actually going to just test out this radical just to see if I can simplify it any further. And by doing that, I mean I'm going to test all the numbers, all the perfect squares that are less than 69. So 64, 49, 36, 25, 16, 9, and 4. Okay. 8, 7, 6, 5, 4, 3, 2. Yeah. So 16. Oh, I know 64 can't divide into it, so I'm not even going to try. And I know 49 because 2 49s would be bigger than 69. I'm pretty sure it's not divisible by any of these, but I'm going to check just to be sure. You never know. Oops. And since all of my values are decimal values, that means that none of them, well, I know my 9 times tables and my 4 times tables, so I know that those definitely aren't going to work, but just to show you. Since all of my values were decimal values, that means that this cannot be simplified, meaning I cannot pull out any further numbers. So this is actually the final answer. And you're going to leave it exactly like that big giant expression. You're not going to do any rounding, you're not going to put this in your calculator, nothing. You're just going to stop right here and leave it in simplest radical form. Let me show you another one. Again, make sure that your equation is in standard form. So 5x squared plus 15x plus 8. Identify A, B, and C. A is 5, B is 15, C is 8. Plug them into your formula. Negative B plus or minus the square root of B squared minus 4AC all over 2A. Okay, now instead of putting this whole thing in my calculator, I'm just going to put the discriminant in my calculator. So this is going to stay the same. This square root sign is going to stay the same, and 2 times 5, I can simplify that. All right, let's put this discriminant in our calculator, see what we get. So 15 squared minus 4 times 5 times 8. Oops, I forgot a parentheses down here. So insert parentheses, there we go. All right, 65. Okay, and I'm pretty sure that none of my perfect squares can go into that. Definitely not 64, not 49, not 36, 65 divided by, what comes out, 16, 5, 4, nope, 65 divided by 9, 65 divided by 4. All right, so nope, there are no perfect squares that can go into that. And listen, this is a whole expression. You cannot, I know you want to, but you cannot do that, okay? Because this says the whole expression has to be divided by 10, not just this part. So I know you're like wanting to reduce that as 3 over 2, but you cannot do that. You cannot do that. You're not allowed to reduce part of a sentence. So this is your final answer. Okay, let's take a look at one that has a little more work to it than just simplifying the discriminant. So again, make sure it's in standard form. Identify your A, B, and C values. Substitute them into the formula. Okay, wrong thing. When I compute my discriminant this time, I have parentheses negative 6. Whoops. And this time the parentheses are important. If you leave them out, you're going to get this a different answer. Because when you square a negative number and it's included in the base, you're going to be squaring that negative sign or writing that negative sign twice. So that's important. All right, so this time I get a 40. So a negative 6 on the outside becomes a positive 6. This becomes a 40, and this becomes a 2. So 40 does have a perfect square factor in it, right? So when you divide and you're checking, right, you can divide by anything, any perfect square less than 40. So that would be 36 25, 16, 9, 4, and 2, right? So if I'm dividing by 4, I know that I have 4 and 10. And 10 does not have any perfect square factors in it, right? So 10 is 5 and 2, or 1 and 10, and neither of those are perfect squares. But this one is a perfect square, and so when I factor this 40 as 4 and 10, that means this can actually be square rooted. So the square root of 4 is 2. So everything else is going to stay the same here, 6 plus or minus, and 2 in the denominator. But my radicand is going to be simplified to become 2 square roots of 10. And now we actually have a little more work to do. Now, this number inside a radical sign cannot be divided by a free number, right? We'll call these the free numbers, and we'll call that radical sign like a number that's in jail, right? So you cannot do any math if you're a free number with the number that's under the radical sign or in jail. But all of these numbers out here are free numbers, and there are 2 terms, this one and this one, and this division bar here says to divide everybody by 2. So I can divide this by 2, and I can divide this by 2. So I should. So 6 divided by 2 is going to be 3, and 2 divided by 2 is going to be 1. So I could write it like this, or I could even leave that off. And this would be our most simplified, simplest form radical answer. Okay, let's try that one more time. So sometimes as you're simplifying your discriminant, you can also simplify the radicand, and sometimes you can even simplify the fraction. So one more time, here we go. A is 3, B is negative 14, and C is 9. Fill that into your formula here. Don't forget to use parentheses when you're typing in your calculator, as well as when you're writing this work on your paper. And A is 3. So here we go. My discriminant is going to be negative 14 squared minus 4 times 3 times 9. Okay. Looks like I get an 88. So positive 14 plus or minus the square root of 88 all over 6. All right, so what we're going to do now is check to see if I can simplify this radicand. Now, I definitely know that 4 goes into this 22 times. And 22 is 2 and 11, right? But there are no other perfect square factors here, so I can't go any further than this. So the square root of 4 can be done, but the 22 cannot. The 22's got to stay. So 14 plus or minus. Now remember, it doesn't come out as a 4. We're taking the square root of 4. So it comes out as a 2. And now, although it's not going to become a whole number, I can reduce these numbers out here, these free numbers, right? So I'm going to reduce this 14 and 6 by dividing both by 2, and that's going to give me a 7. And this one over 3, and this one will also be over 3. So again, I can leave this 1 there, or I could erase it. Okay. Now listen, let's pretend this one was like an 8 or something like that. You can't leave just the number 3 here unless this is reduces to a 3 in the denominator and this reduces to a 3 in the denominator. Okay, so if it reduced to different numbers, we'd have to separate this problem out. Meaning not have one long division bar, but 2 separate bars with their different denominators. All right, so that is how you simplify in radical form. I think it's time for you to try a couple on your own. Here are your 3 questions. Pause the video now and give it a try. Good luck. All right, you ready to see your answers? You get it all the way down to simplest form, even number 3. Here we go. Great job. All right, so that concludes our lesson here on simplifying and using the quadratic formula.